Welcome to the new curriculum of science learning by Ms. Mendez. There are 3 domains of science learning. Those domains are a framework of standards for exploring the natural and human world. Those domains are practices, cross-cutting, and core ideas. The practices of science helps students understand how scientific knowledge develops. For example, direct involvement gives them an appreciation of a variety of approaches that are used to investigate, model, and explain the world. Engaging in the practices of engineering also helps students understand the work of engineers and the links between engineering and science. This is more about what students do when they do a science lab or investigation. There are 8 practices that are essential in the K-12 science. They are 1. Asking questions and defining problems. 2. Developing and using models. 3. Planning and carrying out investigations. 4. Analyzing and interpreting data. 5. Using mathematics and computational thinking. 6. Constructing explanations and designing solutions. 7. Engaging in argument from evidence. And 8. Obtaining, evaluating, and communicating information. An example would be when a teacher does a science activity about the bird beak adaptation. This is where students will test out different materials that look similar to different types of bird beaks and predict which beak is best to get food. Then compare each beak to the other beaks and see which beak corresponds to which bird. Students will be using some of the practices in the lesson, like asking questions, developing and using models, planning and carrying out investigations, analyzing and interpreting data, constructing explanations, evaluating, and communicating information. Cross-cutting concepts. They provide one way of linking across the domains. Each concept also stands alone as one that occurs in all areas of science and is an important consideration for engineered systems as well. This is about how students think and connect the 3 domains of science. There are 7 cross-cutting concepts. They are 1. Patterns. 2. Cause and effect, which have mechanism and explanation. 3. Scale, proportion, and quantity. 4. System and system models. 5. Energy and matter, which has flows, cycles, and conservation. 6. Structure and function. And 7. Stability and change. An example of cross-cutting concept in a classroom is when a teacher creates stations for students to move and gather information about a specific topic which each station relates to. An example would be the bear stations lesson, where students go to 5 different stations and can touch and learn more about how bears' fur feels and how it helps them. There's also the station where students read about why bears are considered mammals. There's also a station where students can learn about bears' habitats. So they can go to these different stations and learn a little bit more about bears, but not specifically one whole thing. Each station has a different idea or information about a bear. Disciplinary core ideas. There are 4 major disciplinary core ideas. Those are the physical sciences, the life sciences, the earth and space sciences, and engineering, technology, and applications of science. These core ideas unify the principles in life sciences and help students make sense of emerging research findings. Each core idea and components are introduced with a question that is designed to show some aspect of the world, and that idea or question helps to explain. This is intended to pose questions about the world and seeking to answer them in a fundamental that is fundamental to doing science. So this is what the students know. So as you can see on the left hand of the screen, I have listed the 4 major core ideas, and each one tells you what will be taught in that lesson. So physical science, you have 4 points there. So you have matter and its interactions. Then you have 2, motion and stability, which has forces and interactions. Then you have 3, energy, and then 4, waves and their applications and technologies for information transfer. Then you have life sciences, you have earth and space sciences, and engineering, technology, and application of science. An example of the disciplinary core ideas would be when teachers take a reading for a lesson that they are going to be doing in a class and see what the students will get from that reading. What will they understand? They also see what other activities students can do in order to create essential questions to focus on the instruction. So for example, the focus question. A focus question is important because that way the lesson can reflect on what the focus question is. And students can answer using the data that they have collected or any readings that they have done in order to answer that question. Thank you very much, and hope you guys have a good day.